Hello, everybody. Today we're going to talk about how to graph parabolas, quadratic functions, essentially. That's the fancy name for the graph. Let's take a look. This is a handout that I sent you. Okay, so there are several things when we graph a quadratic function. One thing is that we note the two forms. Okay, one form is the standard form, which is y or f of x equals ax squared plus bx plus c, that trinomial form. And then the other form is the vertex form, which is y or f of x equals a times the quantity x minus h squared plus k. Now, the first thing we're going to do is we're going to talk a little bit about the vertex. What's the vertex? Well, the vertex is a maximum or a minimum of the parabola, because parabola goes down, then curves back up. That would make the vertex at that curve point, that turn point, the minimum. Or it could go up, then turns back down. And we see that here. Goes down, then turns back up, or goes up, then turns back down. These are the vertices. So that's the vertex for when it opens what we call up. This is the vertex for when it does what we call opens down. Okay. Now at A, whichever form, in this form or in this form, is positive, then the vertex is a minimum. So that'd be the minimum situation right there. If A is negative, then it's a maximum. So it's that situation. Also, if A is positive, we say the parabola opens up. And if A is negative, we say the parabola opens down. To graph a parabola, we go through several steps. First thing we do is we find the vertex. To find the vertex, it depends on which form we have. If we have the vertex form, we automatically are given the vertex. That's why it's called vertex form. If it is in this format, where we have a minus in the parentheses here, then the vertex is at hk. If it's in this form where we have a plus in front of the h there, then the vertex is minus hk. Remember that little adjustment there. It comes in handy to remember, and it gives you a lot less frustrations. When in standard form, we have to use a formula. In standard form, the vertex comes from, for the x value, comes from the formula minus b over 2a. We plug whatever number we get from this formula into the function, and that gives us y. The y-intercept, we should know. The y-intercept, again, is found when x is 0, and we evaluate the function. And we should find the y-intercept, or intercepts. Sometimes there's only one, sometimes there's two. Okay? There won't be any more than two, though. Okay? Now, sometimes if it's complex numbers, there is no x-intercept. Okay? We have to adjust our graphing a little bit. Okay, so now, when the function is in this form, f of x equals 2 times the quantity x minus 3 squared minus 18. Okay? We have a function that's in vertex form. A is 2, so it opens up. That means our vertex is a minimum. The vertex is at 3 minus 18. How did I know that? Because I went back up here to that HK business. It's in this x minus h quantity squared form. So that means 3 minus 18 is our vertex. I plug 0 in for x. I get 0 out, so that's my y-intercept. Now let's see if we have some x-intercepts or an intercept. So I set the function equal to 0. I add 18 to both sides, divide by 2, and get the quantity x minus 3 squared equals 9. Now, when your function is in vertex form, you should use the square root method. It's the most efficient way to go about it. So we plus and minus square root both sides. The square here and the square root will cancel out, giving us x minus 3. And it equals plus and minus the square root of 9. Plus and minus the square root of 9 is 3. So we get x minus 3 equal plus and minus 3. We'll add 3 to both sides to isolate the x, get x equals 6, and x equals 0. We use this information to graph. Okay? I have the graphs on a PDF, so let me stop the share here, right here, and let's look at that PDF. You're going to go back and forth with this. So be calm. Okay, here's our first one. So from what we just did, a equals 2, so it opens up. The vertex is at 3 minus 18. F of 0 is 0. And the x-intercepts are 0 and 6. So we plot the vertex. We plot both intercepts. And then we connect with the parabola shape. I'm going to go back now to the handout. Let's look at example 2. I have another example here. This one is when f of x equals minus the quantity x plus 2 squared plus 6. Now, since there's a minus in front of the parentheses here, that's a minus 1. So a equals minus 1. Since it's negative, it'll open down, and our vertex will be a maximum. Our vertex is at minus 2, 6. Again, going back up to that vertex formula. When you have x plus h in the quantity squared, the vertex is at minus hk. And so we plug 0 in for x, get 2 out, so our y-intercept this time is 2. For the x-intercepts, we set the function equal to 0, solve for x. The only inconvenience we have here is that the plus and minus square root of 6 isn't a nice number like it was with a 9. That's okay. We'll continue on. We'll subtract 2 from both sides to isolate the x. That gives us x equals minus 2 plus and minus the square root of 6, which is 2 answers, the plus and the minus. Minus 2 minus square root of 6 is about equal to, forgot my minus there, minus 4.5. And minus 2 plus square root of 6 is equal to about 0.5. Now, the only reason that I did that, made these decimal values, is because I want to approximate where they were. So it's easier for me to plot them when I graph. Okay. Let's take a look at that. And so for the graph of this, I have f of x equals minus x, minus a quantity x plus 2 squared plus 6. Again, a is minus 1, opens down, vertex is at minus 2, 6. My y-intercept is y equal 2. My x-intercepts are at minus 2 plus and minus the square root of 6. So I plot the vertex. I plot the first intercept at minus 2 minus square root of 6, which was about 4.5, negative. I plot the second x-intercept, which is at minus 2 plus square root of 6. So I have both intercepts plotted. Okay? And then I connect. Talked about this a little bit in the handout. I didn't mention it in this video. But if I draw a line directly straight up and down, vertical, through that x-intercept, or through that vertex, okay? Through that vertex, the graph is symmetric. So what does that mean? So to say it's symmetric is like a mirror image. So think about symmetry this way, and all parabolas are symmetric. If I draw this left half in wet ink and fold it along the line that goes through that vertex vertically, and then press down on the paper and then unfold it, this side would be seen. The wet ink would rub off and make this side. Okay. Let's go back to the document. It has our examples. And let's look at the third example. The third example says f of x equals x squared minus 5x plus 6. A is 1, so it opens up. X, I need to use formula now. Minus b, so b was negative 5. So I have negative and negative 5 over 2 times a. Well, a is 1. So that gives us a positive 5 over 1 because of the negative negative. That gives us a positive, rather, 5 over 2. Now we're going to plug that into the function. We plug it in every place there's an x, and we get minus 1 for it. Let your calculator do the work for you then. So the vertex is at 5 over 2 minus 1 over 4. The y-intercept is at 6. When I plug x equals 0 in, I get 6 because that drops out. That drops out. All we're left with is 6. And then the x-intercepts, I set the function equal to 0. I could have used the quadratic formula, or I can factor here. I chose to factor, and we get x minus 3 equals 0, which gives us x equal 3, and x minus 2 equals 0, which gives us x equal 2. Let's look at the PDF. Our final example. Our vertex, first off, a is 1. It opens up. Our vertex is at 5/2 minus 1/4. The y-intercept is 6, and we have x-intercepts at 2 and 3. We already did that on the previous sheet. So we plot the 2 and 3 as the x-intercepts. The 5/2, which is about 2.5, minus 1/4. And then we connect. And that's it. Now let's go back to the handout one last time, because there's something else I want to talk about on that. You can also put the function into y2 or y1 on your calculator. Whoops. When you do that, you need to set a window. A graphing calculator, to be a good graph, a graphing calculator should include any x-intercepts, y-intercepts, and the vertex. So what this does is gives us a nice boundary of values to use. So since my vertex is at 3 minus 18, and it's a minimum, I don't need to go much below minus 18 for y. Okay? Since my y-intercept is at 0, I don't need to go much beyond 0 for y. My x-intercepts are at 0 and 6, so I don't need to go much to the left of 0 or to the right of 6. So I'm going to set my x values at minus 4, which is probably too much, 7. That would include then the x-intercepts. I set my y value at minus 20 and 22. These are my window values. Okay? And then graph. I can do the same thing for this one. I have a little more concise graph on this one. When I graph this one, let's take a look. So my vertex is at minus 2, 6. My y-intercept is at 0. And my x-intercepts are at about minus 4.5 and 0.5. Okay, so for the x values, I have to include that minus 4.5, and I have to include the 0.5. So if I drop back to 0.5 on x and up to 1 on x, I include that. Okay. Also, on my y-intercept, I have to at least be at 2. Well, if I stop at 2 for y, I don't include the x-intercept, so I have to go below that. And then for the maximum value for y, I have to include the vertex, so I have to go up to 6 at least. I'm going to go a little bit beyond that. So for y, I'm going to go minus 1. That'll drop below the x-axis so I can see the intercepts, and 7. Give it a try. And then the last one, I chose to use x, 1, and 4. Why? Because, well, I have a x-intercept of 2 and an x-intercept of 3. And so that would include those intercepts. And for the x, or for the y values, the y window values, I have a y-intercept of 6. Would this include that? I'll let you find that out. You might have to adjust that a little bit. Okay. And also, I have a vertex at minus 1/4. Okay? So remember, I have to include the y-intercept. If I don't include the y-intercept, then this value might be a little bit off. So I'll let you try to adjust it. In fact, it is. Okay? And I did that on purpose to let you experiment a little bit. All right, hopefully this helps. If you have any questions, please make sure to ask. Also, I hope you noted that the exam window changed. It's now the 12th through the 16th. That gives us a little more time to understand and realize this information. Take care.